I was this close to not getting out of my couch. Ugh. I remember like a year ago or so when I was streaming like twice a week programming because I couldn't do more. Oh, freezing, dude. Oh, I don't like being cold, but I have to be. Terrible. Some tea on the way. Oh. Okay, so it doesn't work. It doesn't work even harder than I remembered. Okay, never mind. I actually did undo everything yesterday, so what I was gonna show doesn't actually exist anymore, so it doesn't matter. We're doing this again, but this isn't exactly how I want to do it. Does that run? Yeah. Okay. All right. All right. All right. There was a bug in here where it started to there was something, it was like fixing kind of, or no, what am I saying? I was undoing it and it started to undo, like it skipped a step in the undo. So it was like undoing things that was commented out, but it was still commented out. So I have no idea what's actually like fucked up here. But this is where we should be. And now I don't know what's wrong. Oh, that's gonna... Oh, that'll suck to figure out. Now, what we're gonna do is let's just start with that right away, because I don't know what's wrong otherwise. The wall writes itself, and then the wall writes this. I don't want it to write empty voxels. I was hoping I would still have something like that, but I guess we can write it again. And then here it should be and wy is greater than, no, equals walls dot get length 0 minus 1. This is x. And then we have and bx equals 7 and x equals 7. There. And then we have an and there. Y, Z. Y, Z. Y, Z. Hello, okay, how's it going? How many socks today, dude? I can't go running. I'm going back on keto now after Christmas still. It takes forever. And all my joints are just fucked up. Like, it's so bad. If I move, it gets way worse. If I wear socks, it gets way worse. For different reasons, yeah. You just got a treadmill. Yeah. No, going out running here it's perfectly safe. I have a treadmill in the basement, I think. No, we tossed it. It was so dog shit. It was, you know, manually it didn't have any motor or anything like that, so it was just, you just had to incline it like hell and then just manually make it roll. A bit of Trembo? I have no idea what you're saying right now. You think my tea is done? Yeah, I think you mentioned that before. You can, but yeah, it would suck. Probably not worth the effort, but I don't know. Drink salt water? Why? But no, you can generally, as far as I know, you can still eat and do keto, but you have to eat like 6 times a day, because you don't, like, you still have gall, but it's like a dribble, so you have to like eat a little bit all the time. Got a tummy ache? I do have a tummy ache. I eat once a day. I also eat once a day. Mostly. Oh! I've been taking ibuprofen and paracetamol every single day for over 2 weeks. And now I started taking another pill instead. And yeah, my tummy is starting to feel like total dog shit. It's really bad. Like, my joint aches are insane. Like, you don't understand. I cannot sleep. It's not possible without taking pills. And even if I take a pill, I wake up 3 to 4 hours later, and it's terrible. I have to get up and get in the shower and just sit on the toilet and have like a little bucket that I put my feet in and just put cold water in it, like ice cold water, and just sit there for a while. And then it kind of goes away for a while. And then if I can go to bed and fall asleep before it comes back, we're fine. I'm 34. Okay, so X, X, Y, Y, Z, 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 Y, X. This needs to be 1, 2, X, Y, Z, Z, Y, X, X, Y, Z. Let's see what happens. To sell a computer on eBay? Why? Wrong. Oh. Okay. So when you want to send information to the shader or to the GPU, you can't just do that. You have to send it via a buffer, and a buffer it's just a one-dimensional array, so it's just a series of numbers, right? So you have to take all of your information and just put it in a long row. Either that, or you can do it via a texture, and the texture can be 3-dimensional. So you can do it pretty niftily via the texture, but the problem with the texture is that you can't modify part of it. Like if you place a voxel or something, like in Minecraft you place a dirt block, and you want to update that, it takes an entire second. Like, it just chugs for an entire second at least. And then it's updated. But the problem with a buffer is that it becomes insanely annoying to deal with all your data. But we're gonna go back to that because I think I can do it better than I was doing. Now, how are we rendering things right now? Not at all. Okay, not at all. Okay. We're running at 29 FPS. We don't see anything. That's cool. That's cool. You see, these walls that we're seeing, they're kind of neat because they don't actually exist. It's just that I put a color when we exit the world or the bounds of the world. So I just color it based on how far the ray has traveled. That way you kind of get a little bit of an effect like this. I think I want to try doing something like that as well, based on how long the ray has traveled when I'm rendering, because then you can add just distance bleach, whatever you want to call it. But yeah, not much here. Just kind of weird, but whatever. Hold on, I have to reply to John's fucking Guild Wars tweet again. Okay, so I don't know why it doesn't work. I'm a little bit curious as to why it doesn't work, but I'm sure it's fine. So what we're gonna do is we're gonna go down here. Here. And we're gonna take this and we're gonna get rid of this, I think. We're just gonna do this. And the length, I think maybe we'll do that for now, just because it's easier on the brain. But what I was doing was I was writing all the voxels in the y-axis first, so from bottom to top. And the reason for that is because whenever tiles are going to get cycled out, we'll cycle out an entire column. That's how a chunk works in Minecraft, for example. So I'm gonna do it the same way. Because I don't want the world to be that tall. I'm gonna have a less tall world than in Minecraft. But at the same time, it's gonna be taller. If I can get that to work. Because what you can do in Minecraft, the world is uniform. Like it's just this tall no matter where you go. And because of that, you have 256, or you had 256 possible heights, right? And that means that since one voxel is meant to be 1 meter in Minecraft, you can maximum have like 200 meters tall mountains or something. Which is kind of lame, but it also doesn't matter for the most part. Yeah, he's 2 meters tall, dude. But what you can do is I'm not going to, like, in Minecraft, it just kind of generates the world as you go, and it's doing it based on Perly noise as far as I know. But what I want to do is I want to pre-generate the world on a low resolution. So I want to make like a low resolution map of the world because I want to generate water and stuff. And if you generate water on the fly, it just sucks. Like you can't do it. If you want water, you have to do it on, you have 1 water level. If you're gonna do it purely on the fly. But because I have this pre-generated map, what I can do is I can make things as high as I want, basically. And to kind of make that work, what you can do is instead of the bottom of the world being 0 and the top of the world being 256, the bottom of the world can be 40, for example, and then you can go up to 300. And if you do that, then you can make slopes and like really, really tall mountains that are actually tall. And you can have actual proper height mountains, and the same with the oceans, kind of. But oceans are a little bit trickier because you can't, like, the ocean is at a fixed level, so you can't go down as far as you would like if you want to be able to have like kilometer depths, you know. You'd have to find some other solution there. I think you could still do it though, but you would basically have to have a separate, like, worlds down there, kind of. And you only generate like the oceans on that like world section. I guess that's the only way I can think of that. What we have to do now is, I was doing, let's see, Morton algorithm. This is what I was doing, and this is why it got so complicated. This is an illustration, a visual illustration of a 3-dimensional or a multi-dimensional array, but made into a 1-dimensional array. So that's what becomes an issue, because when you have this and you've got like a pixel grid, right? Or a voxel grid. You can't just go like this. When you're raycasting, I can't just go to the right and be like, yeah, if we go to the right, we increment by 1 every step to the right. It doesn't work that way. So instead, it becomes like, well, we're here, and we cast a ray to the right. Each step it increments 1, and then once it reaches here, it increments like 500. So it becomes really, really wonky to raycast and find the voxels, because every single step in the raycast, you have to do this calculation up here. Now this is the wrong fader. You have to do this. Wall plus wall times 8 plus wall Z times 64 times 512 times 512 plus brick Y plus brick X plus times 8 plus brick Z times 64 times 512 plus voxel Y plus voxel X times 8 plus voxel Z times 64. And up here we're also flooring the brick and the wall, and we are using modulo on the voxel and on the brick. So every single step is absurd. And this can't be this slow, because this part is what matters the most. Because the raycaster is the renderer, and that's like the core thing of the game that has to run well. So we can't allow it to be like that. So instead, what I'm gonna do is I'm gonna, instead of having this fucking bullshit, it's just all gonna be sorted normally. First you go X, and then that increments the Y. Then you go X, increment the Y, X, and then once you're done with the Y's, you increment Z, and then you do that again. And when you've done that, you don't have to do any math. Because what I'm doing here is, when I am casting a ray, here it calculates which side basically we're incrementing. And all it does is, if it's incrementing X, it adds 1 to X, and that's it. If it increments Y, it adds 1 to X. Or if it's going downwards, then it reduces 1 from X. So we just have like an XYZ index like that. It's just a coordinate. And what you can do instead, I think in theory, is have this index be a one-dimensional value. So it's literally just one integer. And instead, when you increment the X, you add 1, right? But I'm not 100% sure if this is viable. It might not be. We might still have to do a little bit of math, but it's very minor. But in theory, you could just add X like that a little bit. And if you increment the Y, then you add the length of X, 1 step. And if you increment Z, you add the length of Y times X instead, because that way you're kind of incrementing it in one dimension. But the problem there is that you don't know when you're outside of the map anymore. Because if you're at the edge of the map and you still increment X, all it does is it loops around to this side. And it can't understand that this value means that we're outside now. But I could use both. I could have both. Because I just want to avoid doing math every single step. Plus is math, but it's very minor compared to doing like 5 or 6 multiplications, I think. So if I want to do that, it would technically be, or theoretically, be something like int let's call it map index. I don't really like this map value though. And the map index is going to be map position dot x plus map position dot y times view distance times 512 times 512. No, well, what will it be? Because now the 512 bit is that's for counting the whole brick, and the extra 512 is for counting the whole wall. Because otherwise, if you want to go from x to the next x, you have to go through the entire brick and the entire wall, and that's 65,500. No, I think it's 250,000 voxels that you have to iterate through. So this should be view distance times 8. No, times 64. That's what it is. It's times 64. Because all we want is how many x's fit until we get to the edge of the map. And that's going to be the view distance times 8 for one brick, and times 8 again, because we have 8 bricks per wall, and the view distance is the amount of walls. So we get view distance times 64 plus map position dot z times view distance times 64 times map height times 64. That's how you start the map index. And then what you need is you need an int map step. Let's call it that. And the map step is, no, it's an int 3. And the map step is int 3. And it's gonna be 1. And this one is going to be view distance times 64. And this one is this. That's how big the step is in each direction. So now if I want to add the map step to anything, or we want to add it to the map index, what we do is map index plus equals oh, it's not gonna be that simple, is it? Of course. Yeah, what we can do is mapstep.x plus mapstep.y plus mapstep z. And what we can do here as well right away is we can multiply this by raystep. That way we don't have to multiply. Because what I was going to do was multiply map step by ray step, because ray step is the direction of the ray, like you said, positive or negative, and you multiply that by the step direction. But what you unfortunately have to do here now as well is there's a mask down here. This might not end up being super amazing either. Mapstep x times mask.x plus mapstep mask.y. And that times mask.z. It's not as clean as I was hoping it was gonna be, to be honest. But it should be correct. However, the question is if this is worth doing, when I could just multiply it by those things up there. Another thing that you can do is, if we have this map step here without ray step, maybe we'll do it that way instead. Because if we do it this way, then we have pre-multiplied the view distance multipliers that we need. That way we save a lot of multiplications. So when we want to figure out what our index is, all we have to do is we take map position dot x times map step dot x plus, and then it's the exact same thing pretty much. We're just multiplying the positions up by the steps to get the 1D index that we're at. I think that should be fine. Let's go back to brick map here. I did this before. I should have saved that. No, I did save it. Here. There. And what this does is it just writes the voxels in an array, just x by y by z, and then it also writes which no, but we can do that. It also needs to write which brick it is, right? That was something that I had to scrap because I couldn't fit the brick in here because the colors didn't have enough bits. So now this needs to be a buffer Voxel buffer. That's where the voxel buffer ends. Okay. So we're writing this to... voxel data and array. There. And then we're writing new voxel data. And voxel data contains a color index and a brick index. So we need to set the brick index here. Temp brick dot set x 8 y 8 z 8, I think. Then here we write uint brick index. And that brick index, oh. Now this is the brick is divided by 8, divided by 8, divided by 8. And yeah, it should just be like that. Because it still needs to be... It's still an index, or a 1D index, so it needs to be something like that. But this should not be 64 here. This should be 8, 8, 8. That is not a byte anymore. Don't know why it wasn't complaining about the byte. I guess it converts from byte to uint without any problems. So that should be our array. And then in here we also need count written plus plus. And the voxel data buffer goes here, and write data. Seems right, I guess. And now it needs brick texture, blah blah blah, color. This is the old one. And then here we had the bricks. I wonder if we can just write all of them in one go. Nah. Well, yeah, but nah. Again, let's write X first for now. Don't have temp voxel here. we've got brick data, and that is going to be not get brick. Do you get brick by brick? Yes. So we just use our temp brick here. We get the brick. And then this is going to be brick. Brick color. And this is the wall. This is the wall index. And that is pretty much it then. Well, no. Walls.get length. This is not right. Here we've got view distance and stuff. This is what we need. There, and this should be times 8, times 8, times 8. There. And then the temp break should not be like that, and that should be 8, 8, 8, right? Because the values are just lower here, because this is the brick. And I kind of want these to be the same, just so that we have consistency. So where are we now? Let's try running it. Index out of range. Oh yeah, because the wall is supposed to not be anything. Be like that. This isn't supposed to do this anyway. This is supposed to just get the wall. No, wait, this is the brick color. Never mind. And that's the wall. No, I mean, it should be right. The temp brick needs to be modulo 8. That's why. There. Now it doesn't render shit. Why? I don't fucking know. It just doesn't want to render anything. If it doesn't want to work, then we can't force it to work. What size do we have right now? Is it small? 4.8. This does not feel like 4.8. Maybe it is. Either way, let's switch that back to 4.4. Ideally, I would want like 4.8 or 4.10 or something. 4.12 would be even cooler. That's the draw distance. But long draw distance is that's a meme. We can do that later. Now we have to figure out how to draw things again. Now that everything is different and wrong. But I think we'll scrap this map index idea because I have everything set up. And I don't want to fuck around with it. we should be able to just get it to work right off the bat, kind of. Now what we need up here is, in our get voxel, this is going to be this thing again. This is once again going to be another index index 3 equals and here now, to get the voxel data buffer, we're gonna say voxel position dot x plus we can use this. Let's see, can we make this a constant? Map step. I kind of like that idea of having that be up here. Int map step there. And then we set our map step. And then we say voxel position.y times map step.y and plus voxel position.z times map step.z. And that's our whole index now. And then we do the voxel data buffer index 3. And here we're getting bricks in a different manner. But that's not how we are doing that anymore. I don't think that's actually even relevant. Let's just see what happens if we run it now. Black? Why is it black? That's strange. All right, let's change this back. Here we still can't read anything, which is strange as shit. I think the question is, am I actually writing any of this? Do we have anything to read? All right. Let's try doing it this way then. What is going on? Why won't this work? Begin write. Compute buffer start index. Yeah. Let's take a look at our data. Voxel data buffer. There. And it's got voxel data, brick data, wall data, get size. So here it says uint times 2 get data, that's correct. Brick data, uint times 2, that's correct. Wall data, size, uint, that's correct. So all the counts are correct. They're structured, sub-updates. Ah. There we go. How about now? There we go. Hello. It worked way better than I had hoped. All right, so we've got our cube back. We probably also have our little graphical bugs and pops back, but I can't really see them here. So then we tried setting this back. And that off, and then we change this back again. Oh, nice! It's not like I wanted it to work or anything. This looks kind of cool. Like we're in a matrix data room. So what is the problem here then? Is it doing brick data buffer? It's just checking the brick data buffer index straight up. Now we are doing get brick based on the brick map position. So we do have to fix those. Again. Ah, it works. Nope. This is the first time I've kind of seen the wall bricks. Kind of curious. Don't understand why this is happening, but it's kind of curious. Because this this color, this means that it's outside of the world. So that means that somehow, for some reason, it's just going too far here, which means it's somehow not converting back properly or something when it's supposed to. But I know there was like one bug at somewhere that I fixed, that I changed back, I think. Up here we set the voxel. So we check the voxel here. But then we increment the voxel there. So here we should do old voxel equals voxel. And then voxel equals get voxel. Let's fix that. I don't want this to be that way anymore. We don't want the wall position there. We don't want the wall and brick position there. I shouldn't need to do that, but it doesn't hurt. Are we so lucky that it works now? But it runs worse. It does run worse than with the texture now. However, I'm still not sure if traversal level equals 2, then the result id xy equals float 4. And here we're gonna do I test divided by step limit. Zero, zero, one. Turn. Now nothing happens? Hello. So it does work. It is doing the traversal there. So the question is why it runs so poorly. I would have imagined that it would run better this way, though we're doing it now, because we're doing so few calculations now. But somehow doing texture lookups is just that much faster. Than accessing buffers. Now, what I am interested in, though, is what happens if we do it the way it was intended to be? And that means here we write this only. Because this was the intention, right? So now when we look up, it runs at 200. 203. If we look forward, it runs 150. We move up. We look down. Runs 400. And this should be relatively viable, I think. Let's see. What if we do view distance 8 maybe? This is exactly what I was afraid of. But we'll see. It might not be as bad once we implement more stuff. Which we can try doing today. We can try doing that. But when you're like looking ahead like this, the frame rate is pretty shit. Because the rays that are going forward, they are all just checking bricks. Brick, 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 brick. So it never gets to skip anything. And that's the issue there. But the sky rays, they skip very large sections now. Here it only runs at 100, which is pretty shit, to be honest. And I'm not really sure how to deal with that. Because you have to remember that it's running at a low resolution. So in reality it would run way worse. My real frame rate is 68, 70, 80, 85. So it's not running well. No matter how much I wish it was. But again, this is in an empty space. So no matter where we're looking, pretty much, is the maximum traversal. So should we try implementing Perlin noise? Hold on. Where the hell am I? Here. Okay. So we just need Perlin. Let's see. What do we need for Perlin? Unity Perlin. Math F Perlin noise. Okay. The fuck? Oh, there. Public texture 2D Perlin text. Perlin text equals new texture 2D and it's gonna be map width view distance times $64. Yeah. And this is also view distance times 64. X equals... The fuck are you doing? This is so confusing. But sure, whatever. Color X equals new color. No, it's an array. Okay, fair enough. Why is there a color array? No, we're... No, we don't need to do that. We just need mathf.perlin noise. Float poop equals mathf.perlin noise. And that's just xy. Okay, so all we should need to do, we don't even need that. All we should need to do here is we're checking this, right? But this is old now. Let's just get rid of this whole thing. And instead we're gonna do if mathf dot Perlin noise, and then we need an x and a y, and that's gonna have to be this is gonna be annoying though, but it's gonna have to be wx times x plus dx times 8 plus wx times 64. Is that gonna be right? Might be. And then we do the same thing for y. And then we check if that is greater than z, if this is greater than this, but it's in y. This is y, and this is z, right? And then we can see what happens. Nothing! And nothing! But somehow we get a perfectly normal graph. Oh, whoa, shit, what the fuck? That's not right. Oh boy, okay, hello. Oh, this is a value between 0 and 1. That explains that. So this... This needs to be multiplied by something. Map height times 64, I guess. Does it float? It still doesn't work. However, it does seem bigger. The world seems bigger, but Let's see, how is this done? There we go. Hello, we've got some terrain. Kind of. We got some errors here, it looks like. Yeah, it's not rendering correctly everywhere. Now, this... We have to get rid of this, but I kind of wanted to try doing this too. But this should just be sky color like that. But yeah, see, the mask alters the colors, and I think that's fine, but what I wanted to do was I wanted to blend the colors. I'm not sure how to do that. So that the further away it is. But there's one more thing I have to do. Here, I test. I want to do something here. Can you do something like this? I've never tried this before. You do traversal level equals 0, question mark. Then we do itest plus plus, else if traversal level equals 1, then we do itest plus equals 8, and else we do itest plus equals 64. And if itest is greater than the step limit, then we set that, but we also set itest equals a step limit -1, I guess. Nah, step limit. Yeah, that's the 4. So once we're at the 4 loop, break it. Or at the end there. Just so it doesn't keep running itself forever accidentally. And the reason for that is so that the when it enters a brick or it enters a wall, that lets it go way farther, right? Which is nice, but you can't do that. You have to use it to purely accelerate it until it stops. I think. Or until it would naturally stop. Because otherwise... This should no longer be masked like that. This should be draw sky equals true as well, I think. But because otherwise you'll get like completely random draw distances, and if you want to do some kind of effect based on how far the ray has traveled, you can't do that anymore either, because the travel distance just won't be uniform. Well, I don't know what I just did, so let's go on. Huh? Unexpected token plus equals? How can that be an unexpected token? You can't do that in here? So can you do equals I test plus 1? Why are you bitching about this? Oh well, you can just do that, can't you? And then at the bottom here, we'll just do this. Or maybe that's... Oh, okay. Maybe... Yeah. Okay. Maybe that's how you need to do it. I test plus equals. That. Yeah. Well, that doesn't go run very well. It still doesn't like doing it this way. At all. A lot of glitches. Kind of crazy how badly it runs. I don't really understand. Editor loop. Well, that's cool, I guess. But here we don't have that issue. Player loop. Player loop. CPU 80. GFX wait for present on GFX thread. Is that waiting for job, background job? I don't know why people tell you to use this thing, it's completely useless. Yeah, it's still running at like 30 FPS. And it's glitching to all hell. I don't really understand why. I mean, it was working fine when we were not using Perlin noise. More or less, at least. you can tell where it's fucked. Big time. Now, thankfully, I intend to run it at 960 times 540. But that's not a solution entirely. It's just kind of cope. Because it still runs way too poorly. I was hoping that it would run a lot better than it's doing, but how big a world can we make? Let's go up to 20. What are our stats? Does it say? Yeah, that's too big. So this is the absolute maximum view distance we can have, no matter what. No matter what we want. It cannot be higher than this. Well, there is a possibility of having it more than this. And that's that at a certain range, we stop having voxels and we only have bricks. And then after a certain distance, we only have the other one. But we also have a maximum ray step as well, right? So at some point, well, it depends. If I just let the ray travel as it travels on its own, then maybe. I'm still upset that it's glitching out hardcore though. I'm not sure what would be causing it. kind of weird because I didn't feel like we had any issues with this, right? So why would I get strange voxels here now? And here it works just fine, except that if you do pay attention, we still have those little ticks. However, we are also casting the ray 400 steps, which is a long way. So it doesn't really matter here, right? Because we're always hitting the edge, so it's not gonna cull any rays. This is bad. What's happening here? Oh, that's because it doesn't. Yeah. It can't skip anything here. Yeah. It's only natural. But it's not meant to go that far. Not really. And that only happens if there's one gigantic plane there, then you have worse view distance there. But again, that is also why I wanted to do what I was trying to do, where you but what you can do, I think, instead of casting the ray and doing it by step like that, is to check the actual ray distance. And I don't know exactly how I would do that. I think I would change. I would replace this with a while loop, and then I would set a ray distance setting here, and then whenever we do one of these steps here, we would check how far has the ray traveled, more or less. Check the smallest side and see if this side is further than this or that. It would have to be something like float equals min no, not min. No, it doesn't need to be anything like that. Whatever. What we need now is this. This is what we need to get working again. And I don't think it works. No. This is for the last systems. This doesn't work with our current voxel system here. So this is completely fucked. This is super, super heavy. I think. Right. We need to get voxel, and then we need to check this if voxel dot color index does not equal 0. But I don't feel like this is the whole issue, because it's breaking so heavily that I don't really understand what's going on. There. I think that's kind of better. But even if that fixes the voxel level issue, it still probably does not fix the issue. We go back to a Perlin level. No, it's still glitched to hell. But it's super weird too. Just look at it. It's like it's not even remotely correct there. Like what's even going on right there? My speed is too high. And I thought we had fixed all of these glitches. Do you think they're all wall related? It's not. Even just bricks causes it to spaz out. What about just voxels? I think this works. Yeah, so it's still my solution for the brick that's broken. Well, fuck. So what's the problem? I don't get it. Maybe something is just wrong still. Did that? Like, what's going on there? Come on. Please. What are you doing? Hello, Gwen. Thanks for the raid. How's it going? I'm just sad and confused. I'm making a little voxel renderer here, but it doesn't want to work very well, and I don't know why. Very sad. So what could be causing this? It could be this. When I'm raycasting, I have big squares. Let's do that. Sure, whatever. Let's just do it the hard way. There. So I've got big squares, that's voxels that we ray trace through. But then I want to accelerate it, so I have something called a brick, which is basically an empty space where we have already confirmed that there are no voxels with anything in it. But the ray, it's not so simple to ray trace as just casting a ray and checking like every, 3 centimeters or whatever along the ray. It's not as easy as that. So instead you have an algorithm that knows which way we're going to go the next time the ray goes anywhere. So it knows that we're gonna go right, right, up, right, right, up, right, right, up, right, right, up. And the problem is when I go across here, then the ray no longer knows what the hell it's doing, because we've skipped this gigantic space, so it doesn't know where it is in this little algorithm anymore. So we basically have to recreate the ray here and send it off again. And I'm just not so sure it works very well. Because I'm kind of recreating the ray based on because this little ray, it has a distance, right? But I have to kind of reconstruct my position here, but over here, based on this ray. And I just don't know if it's accurate enough. I don't know if the error is even there. Because it might still just be that I missed writing something somewhere. Why is my formatting so wrong? But this is wrong too. What about here? Break position X, Y, view distance times 8. This shouldn't matter, but let's do that. Voxel data, brick data, wall data. I still think it might boil down to the same error I had before. Because it kind of does theoretically have the same problem. The way the DDA ray tracing works is that based on the direction of the ray, you get 3 values. You get an X, Y, and a Z value. And the sharper the direction is towards a side, the lower that value is. So if it's towards X, then X is going to be the lowest. And that's because we're going towards X, X gets incremented the most. Because this value is distance needed to travel, to increment. And the problem that occurs is that occasionally, or I'm jumping ahead, the way it works is that you increment the lowest value out of these. And then you add that into like another value. And then you check, you just keep checking like which value is the lowest. Oh, it's Z, it's Z. Then we add the Z value to Z, and then we increment Z1. Because then we know that now we are at that index, right? But the way I'm doing that is by I'm checking all of the values against each other to see if one of them is lower than the others. And what can happen is that 2 of the values can be identical. And if it is identical, then it iterates 2 steps in one go. And so far, this has been the source of like all the issues that I've had. Because when it does this, it might accidentally like jump into somewhere that it's not supposed to be. And when it does that, it'll read it like it's on the wrong side. And that means it'll give us the wrong color. But This is what happens on when we're only stepping with the voxels. These small steps here. But I think it can also happen here. And I also have a bigger step that's that big, right? So I think it can happen there too. And if that happens, then I'm not just one voxel wrong. If this happens, then I'm like 500 voxels wrong. So that is most likely the issue. It's so strange. You know what? Let's do this. In the... Here, traversal level 0, that means voxels. If we go down here to traversal level 2... Did I go too far? Yeah, here, traversal level 1. Then we step there, but what if we say result id.xy equals float4, and here we'll do I test dot divided by step limit. These need to be floats. Float. 0, 0, 1. Return. And then we'll do... No, it has to be if... Here. If we have two masks that are true, or three masks, that can also happen. It's super rare, but it can happen. Then we do that. And then we go and we also do it down here with the wall. And then we run it and see what happens, but I doubt that is what the issue is. No. No, it's some other bullshit. Alright, just to be sure. Let's just return one here. So, because otherwise it might be borderline black. And I might not be able to tell. But it's not the issue. That is super strange though. Like, I don't understand how that can happen. Because the blue is when we are outside of the world. So how can that be outside of the world? Like, I understand over there on the right side. Actually, let's make sure what we're seeing. Because I set draw sky here. Let's remove draw sky there. Now it'll draw black when it runs out of steps. So there it's running out of steps, but I kind of understand that there. But most of these fucked up glitches don't seem to be that. Like there, for example. That's more like the ray is like losing direction. It's really, really strange. I kind of don't know how there might be any real issues. Let's cry. Did I drink all my tea? No, I didn't. And it's cold now, so I don't really want to drink it. There are a couple of possibilities, but it's just like I might just have something wrong in the ray tracer here, because I've been changing it a lot. So there might just still be something wrong in the voxel or in the brick and the wall steps. I might be, but it doesn't feel like that is probable. But there might be some errors when I'm setting the brick, Because what I'm doing is, when I write the voxels to basically a big array, and each voxel also has, it has an index for a brick. So if I find a voxel, then I can just check the voxel's brick index, and then I go to the brick buffer, I pop in the brick index, and it gives me the brick that it belongs to. But that might be off. So I don't really see how, because the math there is pretty simple, I believe. But it could still be. Here we write the voxels. So what I'm doing is I'm setting all the voxels in the x-axis first, and then I go up one in y and I set the x again. So to do that, we have to go through multiple walls. A wall is, it's a brick contains 8 times 8 times 8 voxels, and a wall contains 8 times 8 times 8 bricks. And so what I do is I just go through the view distance times 64, map height times 64, view distance times 64. And I divide that by 64 to get the wall, right? And then we access the wall that way. And then I have a voxel, and the voxel is x modulo 64, which means it goes from 0 to 63, and then when it goes to 64, it loops around to 0 again, and it just goes around like that. Because each wall contains 64 times 64 times 64 voxels. So here, when I'm writing the voxel's color index, all I'm doing is I'm accessing the wall and the voxel in the wall, and then I grab the color index, and that's what we write. And that works just fine. And then here we write the brick, and the brick is x divided by 8, y divided by 8, z divided by 8. So that's temp brick x plus x times view distance times 8 plus temp brick z times map height times 8 times view distance times 8. And that should just be correct, right? It's just 1, 0, 1 when it's on the temp brick, and once it gets to the y, thanks for the sub, Serby. Oh. So this doesn't seem like it's an issue. But what if we go up here? This is where we have the brick. And now we are iterating through the same, except it's times 8. Down here it's times 64, because in each direction there are 64 or each brick has 64 voxels in each direction. So it's view distance times 64 or map height times 64 for the height. And so here it's times 8 because this is a brick. Each wall contains 8 bricks, so we just need to do that. So here to get the wall, we do x divided by 8. And to get the brick that we need to set, we again do a modulo 8, y8, z8. So we just get the color from the temp brick, temp blah 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 blah. And it should be fine. And then we set the, because the brick has a wall index. And that's just temp wall plus temp wall y times view distance. Temp wall z times map height view distance. And I don't see any issues. This also looks fine. So what could be the issue? Is it just that we're traveling too far? Like the ray just loses accuracy? Because we can try setting this back to like 500, and then we go for a where is it? Oh, good job, you deleted it, you stupid idiot. If traversal level is greater than 0, then traversal level equals 0. Equals 0. Now it runs like dog shit, but we can see that it doesn't seem to have any major issues here. But it can't really have any major issues. I think I do see some issues though. But I think it's just resolution related. But I like for the get brick, I'm doing the exact same thing as for the voxel data. So I don't understand how it could be wrong there. Because we do get voxel all the time and it works just fine. There might be some errors here still. Here, in like the orders of how I do this. But I don't think so. See if anyone responded. DDA. Branchless. Nope. And if we get stuck here, then we probably have to do what I was hoping to not do, which is finding another DDA algorithm altogether and just having a different setup. Because the branchless one, if it doesn't work, then it doesn't work. Like, it's that simple, right? So but it does work. That's what's so annoying. Like it does work, but for some reason, the second I implement these area skips, it breaks. And you can't debug it, so you just don't know what's happening. Like it works so well, and then it just doesn't. I don't even understand. Like it's just like in the middle of fucking nowhere. It's just like, oh no, here it doesn't work. Okay, why? No, it just doesn't. Fuck you. Okay, I guess. Thanks. Like, what is that? And it's like it works perfectly for it. Like it's like it's just fucked up over there. Why? Nobody knows. And it's just like from certain angles too. I don't know, man. And it doesn't feel like it makes real sense, because what's happening is that it's skipping that whole... See, that what's happening is that it's skipping a brick there. But why is it skipping a brick there? And why is it like only fucking random? So it's like at a certain distance, it's like the algorithm just glitches out. Could it be that it's like... It could still be that it's doing a double step, because if you think about it, when the voxel level does a double step, if it steps into an empty brick, then something might happen. I don't know. Something might happen. But I think it might overshoot, or rather clearly it is overshooting somehow. And that it comes back to that, and it's the fundamental feature of this DDA setup, that it has this mask solution for deciding which step to take. And it's just not good. So we have to try branching it. But I think that'll be it for today. Short stream, but I pushed the terrestrial stream a little bit extra. And we're at the end of this road, so I don't feel like starting anything. But we've made progress. Unfortunately, the progress usually ends up with me having to delete half of everything. So, very sad. Anyway, we'll stream more tomorrow. Until then, thanks for hanging. Have a good night. Bye-bye.